Hey everyone, today we're going to discuss about the properties of a logarithm. So whenever we deal with logarithmic equations, there are several properties that we can apply. Now these properties will be very handy later on when we start evaluating values of logarithmic equations and inequalities. So the following are the properties of a logarithmic equation. If b is greater than 0 and b is not equal to 1, then the following properties are true. First is the logarithm of 1 to the base b is equal to 0. B here stands for any real number greater than 0 but not equal to 1. So as long as your argument is 1, then the exponent is 0. Second is the logarithm of b to the base b is equal to 1. So in this case, if your argument and your base is equal, then this means that the exponent is equal to 1. Regardless of whatever the value of b here, as long as it's greater than 0 and not equal to 1. For the third one, we have the logarithm of b raised to x to the base b is equal to x. In the same manner, b raised to the logarithm of x to the base b is equal to x. So if we have an argument raised to an exponent and the base of the argument is equal, then the exponent is the exponent of the argument. So for our number 4, we have if logarithm of x to the base b, logarithm of x to the base b is equal to logarithm of y to the base b, this means that x is equal to y. If the logarithm of two arguments are equal, then it means that the arguments themselves are equal. This will be very handy later on when we deal with logarithmic equations. Next, on number 5, logarithm of c to the base a. C and a are any numbers as long as a is greater than 0 and a is not equal to 1. This means that logarithm of c to the base b over logarithm of a to the base b. This is what we call the change of base formula, and this will be very handy later on when we deal with laws of logarithm. Now, next, the sixth property is logarithm of b to the base a is equal to 1 over logarithm of a to the base b. If the argument and the base have been flipped, then it's equal to 1 over logarithm of b to the base a. So they're reciprocals of one another whenever you flip the argument and the base. For number 7, we have logarithm of 10 is equal to 1. Take note that there's no base written, so this means that this is a common logarithm. In the same manner, ln of e is equal to 1. Again, ln is the natural logarithm. Number 8, logarithm of 10 raised to x is equal to x. This is a common logarithm, base of 10. And ln of e raised to x is equal to x. For number 7 and number 8, they are related to the previously mentioned properties of logarithm. So there, it also applies to the common logarithm and the natural logarithm. So these are the properties that we can use in order for us to solve for the values involving logarithmic equations. So be familiar with this because these properties will be applied on our next lessons to come. So I hope you guys learned a lot today and see you guys in the next video.